Hello, everyone. My name is Courage, and today we'll be looking at radiation. So our learning outcomes for today include explaining what radiation is, and we'll look at the types, the sources, the applications of radiation, as well as radiation safety and shielding. So we'll look at what radiation is, we'll categorize radiation, and then we'll look at some of the natural and artificial sources of radiation. We'll also try to debunk some of the myths that are associated with radiation, and then we'll look at the applications of radiation. In the last part of this lecture, we'll then look at radiation safety and shielding. Right, so shown on the screen are 4 images, and just to test your background knowledge about radiation, which of these images do you recognize, and what do you think they represent? So at this point, you can pause the video just to analyze these images and tell us which of the 4 you recognize. All right, so the first image, A, actually represents an X-ray image of the chest, whereas B is a radiotherapy treatment of a cancer patient. So the machine that is used here is actually called a linear accelerator, which is the one which actually produces and delivers radiation treatment. Image C is actually an explosion of a nuclear bomb. Probably some of you have seen this, maybe in movies or somewhere on the internet. Whereas D is actually, these are cooling towers for a nuclear power plant that is used to generate electricity. So what is radiation? Radiation can be simply be defined as energy in the form of waves or particles that travels through space or in a medium. And of course, this radiation can interact with matter and therefore depositing some of its energy and leading to effects like ionization and other effects. So we can categorize radiation into 2. We can either categorize it as ionizing, that is the type of radiation that is able to remove electrons from atoms, or we can categorize it as non-ionizing, which is the type of radiation that does not have sufficient energy to eject or to remove electrons from atoms. So ionizing radiation can remove electrons depending on the type. There are 2 ways in which this can be done. So if the type of radiation is charged particles like electrons or alpha particles, then we'd call this directly ionizing radiation. In other words, it can actually deposit its energy directly into matter. Whereas indirectly ionizing is the neutral type of radiation, like photons, which could be in the form of X-rays or gamma rays, or neutrons, which are basically neutral particles, right? As for non-ionizing radiation, examples would include radio waves, ultraviolet and infrared that we can get from the sun, microwave radiation that also comes from our microwave appliances at home, as well as visible light, right? So while non-ionizing radiation does not have sufficient energy to cause much damage, ionizing radiation, on the other hand, can damage DNA through ionizations. And so this would be our main concern concerning the use of radiation. So we'll limit our scope today to ionizing radiation. So let's look at some of the sources of radiation, which can be divided into 2 broad categories, natural and artificial. Natural radiation basically constitute the majority of all the radiation that we encounter. And most of this type of radiation is from cosmic radiation, which is the sun, the stars, supernovas, and the other part is from radon gas, which is obtained from the decay of uranium that occurs naturally underground in rock, soil, and underwater. On the other hand, we've also got artificial radiation, which is mostly from medical imaging, such as X-rays and CT scans. So let's debunk some of the myths that are associated with radiation. One of these myths is that all radiation is harmful. Other people say radiation exposure always leads to cancer, and other people would even go on to say eating bananas can expose you to dangerous levels of radiation. The 4th myth is that cell phones and microwaves emit dangerous radiation. Well, this is not all true. For example, point number 1, which says radiation is harmful always, is not true because, for example, the sun exposes us to UV, visible light, and infrared radiation all the time, but it's not harmful always. Also, we can regulate the amount of exposure, like in medical imaging, and this is generally considered to be safe and actually beneficial for diagnosis. Microwaves and cell phones actually emit non-ionizing radiation, which can generally be considered to be safe. And bananas are not dangerous in terms of the radiation contained within them. They do contain potassium-40, which is a naturally occurring radioactive isotope. However, the levels of radiation in bananas are extremely low and can be considered to be harmless. So what are some of the applications of radiation? Well, I've already highlighted some of these, but these could include diagnostic X-rays, like CT scans, which is the first image here, used to detect fractures, infections, and tumors. We can also use radiation for radiation therapy for treatment of cancer in the second image. We can also use radiation therapy for security, like baggage scanners at airports for security reasons. We can also use radiation to irradiate food to kill pathogens so as to preserve food. So at this point, you can pause the video and scan the QR code, or alternatively, you can click this link for Mentimeter, and then you can answer the question, which says, which of the following uses ionizing radiation? We have got chest X-ray, MRI, ultrasound, and thermal or infrared imaging. All right, so the answer here would be chest X-ray, as MRI does not use any ionizing radiation. It actually uses magnets and radio frequency pulses or waves. Ultrasound actually uses high frequency sound or acoustic radiation, which is non-ionizing, whereas infrared or thermal radiation is actually non-ionizing radiation. So our answer here would be A. Let's look at now the effects of radiation exposure. So the effects would depend on the amount of radiation and also the time of exposure, as well as the surface area exposed. So if you're exposed to high amounts of radiation, you may develop acute radiation syndrome, which includes burning of the skin, vomiting, nausea, or even organ failure. All right. If you're exposed for a very long period of time, you may develop cancer in the long run due to genetic mutations. Right. You may also encounter alterations of your DNA. So on the figure here on the right side, so the patient on the left here actually is suffering from acute radiation syndrome, which only occurs for high exposures. Right. The figure on the right shows DNA damage, which may later cause birth defects in future generations. So these are some of the effects of radiation. So how can we protect ourselves from radiation? Well, we can use the ALARA principle. ALARA stands for as low as reasonably achievable. So it's basically a radiation safety principle, which is aimed at minimizing the amount of exposure by implementing 3 key strategies, which include minimizing the amount of time that you're exposed, maximizing the distance between yourself and the radiation source, as well as using shielding. So if you double the distance from the source, you actually decrease the amount of radiation by a factor of 4. This is actually due to the inverse square law, all right? So if you double the distance, you would quadruple, you'd actually decrease, rather, the radiation dose by a factor of 4. How can we shield ourselves from radiation? Well, this depends on the type of radiation. If it's alpha radiation, then we can stop it. Alpha radiation is pretty easy to shield, as it is not that penetrating. This is because it's heavy and it's charged. So it can be stopped by a plastic, paper, or even air. Beta radiation, on the other hand, is a little bit more penetrating because it's lighter. Beta radiation is basically electrons. So this can be shielded by low atomic number materials like aluminum. X-rays or gamma radiation is a bit more penetrating and would need high atomic number materials like lead, concrete, or even tungsten. Right. Neutrons are the most difficult to shield. And to shield neutrons, you need hydrogen-enriched materials like polyethylene or borated concrete. The reason why we need hydrogen is just to increase the cross-section for the absorption of neutrons through elastic scattering and absorption. All right, so now just to test your knowledge on what we've covered so far, can you scan the QR code? You can pause the video at this point, scan the QR code or click the link, the Mentimeter link, and answer this question. So basically here you are required to rank this radiation type from the most penetrating to the least penetrating through human tissue. All right, so the correct ranking here would be neutrons would be the most penetrating, followed by X-rays / gamma rays, which are pretty much on the same order of penetrating power, followed by beta rays or X-rays, actually beta particles, and then lastly, alpha particles. So lastly, let's look at how you can estimate the radiation dose that you actually receive yearly, whether from background radiation or from CT scans, or this really depends on the type of occupation that you are involved in, right? So if you click this link, it will take you to this website that actually asks you a bunch of questions. If you fill in those questions, it would estimate the amount of radiation that you're exposed to, okay, based on your lifestyle, whether you are a member of the general public, whether you are a radiation worker, whether you have been on a lot of flights recently. Of course, if you fly a lot, you would be exposed to more cosmic radiation from the sun. So if you answer those questions, you would get a figure. And what I want you to do is to compare that figure with the dose limits that are recommended by internationally recognized radiation protection standards. So in this table here, we have got those dose limits. So once you get those values and do a comparison, please share with your colleagues on my e-learning discussion portal, just to see what others are getting, and also to discuss what factors you think contributes most to your dose and how do they compare to the regulatory dose limits, and to tell us why you think the results you are getting make sense to you or not. So just to summarize what we covered, radiation can be very useful if used responsibly. And most of the fear that people encounter about radiation is due to lack of knowledge or misinformation. And we need to use the ALARA principle for radiation safety. And in terms of shielding, we need to first look at the type of radiation in order to come up with the best or the most appropriate type of shielding material. You can click on this YouTube link. This video would actually explain or summarize what we covered. Alternatively, you can just click here and then it will actually play and you would actually be able to view a summary of what we covered in this lecture. All right. So let us know if you have any questions. You can alternatively contact me on the email given if you have any questions. I want to thank you all for your attention. Bye.